Good morning, students. In this video today I'll discuss about chapter 12 of class 12 chemistry. The topic is aldehyde, ketone and carboxylic acid. In this chapter you have to separately study about aldehyde, ketones and carboxylic acid, preparation and their chemical properties. Okay, so first you have to know what are aldehyde and ketone. You have already studied in class 11, that is aldehyde group means CHO and ketone group means C11O. Okay, and only C11O group is known as carbonyl group. In aldehyde, the carbonyl group is joined with one carbon containing group and with one hydrogen atom. But in ketone, the C11O group is attached with two carbon containing group on both sides. Okay. So in aldehyde, mainly CHO group is present. In ketone, C11O group is present. Nature of carbonyl compounds. Carbonyl compounds. In carbonyl compounds, the C11O group is polar group, polar in nature due to difference in electronegativity between carbon and oxygen. Carbon becomes positive and oxygen become negative because oxygen is more electronegative. Okay. So the C11O bond in carbonyl compound is polar covalent bond. The electronegativity of oxygen is much higher than that of carbon, so their electron cloud is shifted towards oxygen, and therefore carbon oxygen bond is polar in nature. In any carbonyl compound, that is in aldehyde, ketone, the C11O bond is always polar in nature. Next, nomenclature is given. It is not important. For IUPAC nomenclature of aldehyde, you have to use the suffix L. For example, HCHO. The IUPAC name is methanal because one carbon atom in the aldehyde. So methanal, one carbon means root word is methane plus L, methanal. CH3CHO, two carbon atoms and CHO group is present. So for CHO group, aldehyde group, L suffix you have to use. So it is two carbon and L, so ethanal. Okay, and common name of HCHO is formaldehyde. Common name of CH3CHO is acetaldehyde. Okay, IUPAC name, common name you have already studied in class 11. Similarly, for IUPAC name of ketone, for ketone you have to use the on suffix on. For example, CH3CO CH3. The smallest ketone is made up of 3 carbons. Okay, this is the smallest ketone, and the name of this compound, this ketone, is acetone. This is common name, acetone, and its IUPAC name is propan-2-on, that is propanone. This is propanone. Okay, so for ketone you have to use suffix on. For aldehyde you have to use suffix L. Preparation and chemical reaction, these two are main important topic. Preparation of aldehyde and ketone. First preparation is written oxidation of alcohol. When alcohols are oxidized, it is converted in when alcohols are oxidized by oxidizing agent, alcohols are converted into aldehyde and ketones. Okay, primary alcohols converted on oxidation, primary alcohol converted into aldehyde, secondary alcohol converted into ketone. Remember that. For example, oxidizing agent chromium trioxide. Chromium trioxide is used. Chromium trioxide, copper oxide, all these are used as oxidizing agent. When chromium trioxide is when primary alcohols, that is RCH2H, this is primary alcohol, is heated with chromium trioxide, the CH2OH group of primary alcohol is converted into CHO, like CH3 CH2OH. This is primary alcohol. When primary alcohol reacts with chromium trioxide, it is oxidized to aldehyde. that is CH3CHO. The CH2OH group is converted into aldehyde group CH3CHO. Similarly, when 2-degree alcohol, that is, this is the 2-degree alcohol and the previous one is 1-degree or primary alcohol. 2-degree alcohol on oxidation gives ketone. Okay, that is the CHOH group of 2-degree alcohol is converted into C11O group. Remember that. Okay, so when aldehydes are treated, primary alcohols are treated with chromium dioxide, that is oxidizing agent, aldehyde is formed. When 2-degree alcohol, that is RCHOH R dash, when 2-degree alcohols is treated with chromium dioxide, ketones are formed. Okay, so preparation of aldehyde and ketone from alcohols. Okay, first preparation is oxidation of alcohol using chromium dioxide oxidizing agent. Second reaction is hydrogenation of alcohol. It is also oxidation reaction. When primary alcohols are heated with copper at 573 Kelvin temperature, primary alcohol is converted into aldehyde. Similar process. This is also oxidation process. When primary alcohols are heated with copper metal at 573 Kelvin temperature, the CH2OH group of primary alcohol. Remember the change. When primary alcohol, that is RCH2OH, is heated with copper in presence of copper at 573 degrees Celsius, 573 Kelvin, hydrogen is removed from the primary alcohol and the primary alcohol is converted into aldehyde RCHO. Remember the change. CH2H is converted into CHO. Similarly, when 2-degree alcohol, that is RCHOH R dash, is heated with copper at 573 Kelvin, the CHOH group of 2-degree alcohol. The CHOH group of 2-degree alcohol is converted into ketone and hydrogen is removed from the substance. Okay, these two are known as dehydrogenation reaction, that is removal of hydrogen from alcohol in presence of copper catalyst. So these two are oxidation reaction, oxidation by chromium trioxide or oxidation by copper. Next, preparation of aldehyde and ketone from alkenes, and the method is known as ozonolysis reaction. According to the syllabus, you have to read this reaction. When alkenes are treated with ozone in presence of when alkenes are treated with ozone in presence of ozone, zinc and water, O3, zinc and water, aldehyde and ketones are obtained. For example, when ethylene CH2 double bond CH2, this is an alkene, is treated with ozone, that is O3, and in next step zinc and water. Finally, you have to cut this double bond and you have to add 2 oxygen on both sides, and the product will be CH2 double bond O, that is formaldehyde, plus O double bond CH2, that is both is formaldehyde, OCH2 or CH2O, CH2 double bond, both are formaldehyde. Just you have to cut the double bond from the middle and you have to add 2 oxygen on both sides. And from this side you will get RCH double bond O, and from this side also you will get RCH double bond O, that is 2 RCHO you will get. This is known as ozonolysis of alkene. One more example is given. This side benzene ring and this is cyclohexane ring. When O3 and zinc is used, this alkene, from this portion you have to cut this alkene and add 1 oxygen in this left side, and one oxygen in the right side. So the product becomes benzaldehyde and cyclohexanone, one aldehyde, one ketone. So using ozonolysis concept, using this method, you can prepare aldehyde and ketone. Okay. Next, preparation of aldehyde and ketone from alkynes. Preparation of aldehyde and ketone from alkynes. This method is known as hydration reaction. That is addition of water. Okay. So when alkynes are treated with water in presence of mercuric sulfate and sulfuric acid, the alkynes are converted into aldehyde or ketone. For example, when acetylene, that is CH111CH, is reacted with HgSO4, mercuric sulfate, and H2SO4, this reaction is known as hydration reaction uh, because 20% H2SO4 is used in this reaction. 20% reaction, and temperature decreases almost 60 degrees Celsius. Okay, gently heating of alkyne with mercuric sulfate and H2SO4, 20% H2SO4, 1% mercuric sulfate. Uh, so large amount of water is present in 20% H2SO4, and so the reaction of alkyne with water gives aldehyde or ketones. When acetone is used, you will get acetaldehyde. When other alkyne is used, then you will get ketone. Okay, so other alkynes like RC111CH, this is alkyne. In presence of 1% HgSO4, 20% H2SO4, this alkyne react with water to give acetone. Okay. Next method of preparation of aldehyde and ketone. It is from calcium salt of acid. That is, the process is known as by heating calcium salt of acid. Calcium salt like RCO2Ca, calcium salt of carboxylic acid. When heated, aldehyde or ketones are formed. Okay, so when two molecules of calcium salt of an acid is heated, then you will get uh, you you will get ketone and calcium carbonate. But when calcium salt of a carboxylic acid is heated with calcium formate, then you will get aldehyde, not the ketone. Okay, for preparation of aldehyde, you have to heat calcium salt of an acid with calcium formate. And when two similar type of molecules of calcium acetate are heated, then only you will get ketone, not aldehyde. Okay, for preparation of aldehyde, you have to take calcium formate and other calcium salt of carboxylic acid. And for preparation of ketone preparation of ketone from calcium salt of carboxylic acid, you have to take same type of two calcium salt of carboxylic acid. Okay. Next, preparation of aromatic aldehyde, that is benzaldehyde. The method is known as Rosenman reduction. Rosenman reduction. This is the preparation of benzaldehyde from benzoyl chloride, benzene and COCl. Above benzene, COCl group is present, and the reagent in Rosenman reaction are H2, palladium, and BiSO4. When benzyl chloride, that is benzene COCl, is reacted with hydrogen in presence of palladium and BiSO4, the COCl group is converted into CHO group. That is, the acid chloride, benzyl chloride, is converted into benzaldehyde. Benzaldehyde is aromatic aldehyde. Okay, so using Rosenman reduction, you can prepare benzaldehyde from benzoyl alcohol. Using this method, you can prepare other aldehyde also. Okay, But formaldehyde cannot be prepared by Rosenman reduction, because for preparation of formaldehyde HCOCl, formyl chloride, is required, which is unstable. Next, preparation of aldehyde from nitriles. Nitriles means cyanide. The reaction is known as Stephen reaction. When alkyl cyanide RCN is treated with essential to an HCl, concentrated HCl, and essential to reagents are essential to plus HCl. RCN is the substrate. When RCN is treated with essential to an HCl, the RCN is converted into the cyanide group will be converted into CHO group, aldehyde group. Okay, so to convert cyanide group, nitrile group, CN group into CHO group, you have to use Stephen reaction. In this reaction, you have to use stannous chloride essential to plus HCl, and in second step you have to give H0 plus. In single step also you can write. So if you want to write in single step, you have to write RCN plus essential to plus HCl, and water also you have to write in a single step. Then finally you will get RCHO. Okay. Preparation of aldehyde from nitrile alkyl cyanide, and this reaction is known as Stephen reaction. Ether reaction, preparation of aromatic aldehyde, that is benzaldehyde. Ether reaction, important reaction. In ether reaction, toluene is finally converted into benzaldehyde. Toluene is converted into benzaldehyde. In this reaction, toluene is first heated with chromyl chloride CrO2 Cl2 in presence of carbon disulfide. Toluene plus CrO2 Cl2 carbon disulfide. The toluene is converted this type of intermediate CH. The CH3 group is converted into CHO CrOH Cl2 whole twice, and on hydrolysis this intermediate decomposed to give benzaldehyde. Preparation of benzaldehyde ether reaction, important. And you can prepare ketone from nitrile or cyanide using Grignard reagent, RMGX. Grignard reagent means RMGX. Alkyl magnesium halides are known as Grignard reagent. When Grignard reagents are treated with alkyl cyanide, the alkyl cyanide group is converted into ketone group. Okay, for example, when CH3CH2CN, this nitrile, ethyl nitrile or ethyl cyanide is treated with C6H5 MgBr. This is Grignard reagent in ether medium. Okay, this C6H5, this negative part of Grignard reagent will join with the carbon of C111N. Okay, and the C111N becomes C11N. Okay, and on further hydrolysis, the C11N MgBr is converted into ketone like CH3, C2H5, CO, C6H5. Okay, so using Grignard reagent and alkyl cyanide, you can prepare ketone and opener oxidation, Friedel-Crafts acylation not required. Physical properties of aldehyde and ketone, it is all not important. And now you have to study about reaction of aldehyde and ketone, and I will discuss about this in next class.